All right, hello and welcome. In this example, we are going to look at how to determine the voltage source when we're given the frequency, a capacitor, and the current running through that capacitor in RMS. Right, so the first thing we need to do is what we're actually looking for. So we know that voltage is equal to Ohm's law. So we'll grab out our Ohm's law, voltage, current, and resistance, and we'll figure out how we're going to get to voltage from these values. And we know that if we want voltage, then we can multiply our current and our resistance. So we'll say that our voltage source, what we're actually looking for, is equal to our current total multiplied by our total resistance, RT. In this case, we actually have a capacitor, so we don't even have an RT, right? We have capacitive reactance. So we're going to say XC, and that's going to be the resistance of our capacitors, right? It's going to be our version of resistance for capacitors. They're not actually resistance, they're a level of reactive resistance, right? And so we're going to use that, and we're going to call it capacitive reactance. And so that's our first goal, is to figure out what is our XC so that we can plug it into Ohm's law. So we're going to jump back one more step and say that our capacitor needs to be dealt with now, because we were given nanofarads. And so we need to figure out what XC is. And we know that that is our 1 over equation for 2 pi, that's our circle there, multiplied by our frequency, multiplied by our CT. Right? And we know most of this already. They were given. So we know the frequency was given to us at 1,200, so 1200, that's in hertz. And then our CT was given to us. We only have one capacitor, so it's actually 0.2 nanofarads. And so we'll plug that in. We'll say that that is 1 over 2 pi times our frequency of 1200 times our 0.2 times 10 to the negative 9. And that is our total capacitive reactance for the circuit. We'll say that's XC is equal to, and we'll move that decimal point over, so it's 663 kilo ohms, right? XC is in ohms, and that's really important for us. Otherwise, we cannot use Ohm's law, right? We have to get some kind of ohmic value out so that we can apply Ohm's law. And so if we don't do this XC step, our answers will be wrong, because we'll be using our capacitor farad value instead of our ohmic value. Okay, so let's plug into Ohm's law next. We know our two values here. We can write them out even. We can say that our voltage source is equal to our total current, IT. We know what that is. That's 0.6 milliamps RMS, which means that our voltage source is going to be an RMS, right? And then we can multiply that by our XC, 663 kilo ohms. We know that these two will probably cancel out. This is a -3, this is a +3, and if we are to add these together, because we're multiplying, our exponents will add, we'll end up canceling these two out. So we can actually just do the base. We can say that we have 0.6 multiplied by 663, and that gives us a base number out, large one. So we'll say that our voltage source for this circuit is equal to 397.8 volts RMS. All right, let us know if you guys have any other questions.